Hello to everyone. Some students asked me to make some videos about how the tasks are done, and I decided to do that about the lecture 7. As you can see here, we will learn how to create like custom tools for ourselves. And for example, sometimes we need to have a cable connected to the robot, and we want to simulate how the robot will move when it is connected to this cable. And then the second part, which will be self-study, basically, that you have to go on your own and based on what we have learned so far and the material that is inside the rapid commands file that you have, we have in the study material. You have to go to there and search for some tools, see how they are used, and use them in the exercise 7. So the first part is very easy for any type of tool that you have designed. For example, in some application, you make a 3D model. You can make basically the 3D model in any software that you have. For example, I use the Solid Edge for making a tool here. Let me make the simple project right now. I'll show you how the process will go. Station, create a empty station I make. Now I have this tool. Solid Edge file is here. This one, self-made tool. I drag it and drop it in the. You have to just drag it and drop it in here. I don't know what. Okay, I think the recording is going on. Yeah, I'm new about this software also. So, okay, this is how you drag and drop the tool to here. Then I will go, as you can see, this is my Solid Edge design. I would rotate it to match this direction basically, so that I have X in this direction. Yeah, but to be sure, I will go to the positioning, set its position. I have here minus 90, should be minus 90. Here 0, and here also 0. So if I have this, I click apply. So I'm sure that that was close. So I have the tool positioned here. Now I need to design a frame for it. Create frame. You need to activate this one for the surface, and then you come here. You can see this should be active here. A frame position. You click on here, and all of the information is saved there. Great. So I have this here, and now I come to the frame. I want it to be perpendicular to the surface. So I put it set normal to surface, and here I come, and I think this I don't need. I just have to select the surface. Let me see in the material you have the guide, because as far as my memory says, let's go forward with this. create frame, yeah, as it's shown. Then we go to the set normal to the surface, and this will be clear and apply. So let's do the same frame, set normal to surface. And, oh, here I have to first activate this one and then go here. Base self model tool, apply, and if I press the apply, I will have such a norm, such a frame on tip of the tool. It's called TCP. Let's follow the guide. Yeah, we have the same thing here. And then we need to define it as a tool also. It's just right now it's just a model. We define the frame for it, and now we have a tool, create tool here. That the TCP information will be step 2. We can put 00 for position and orientation frame so that we can define it later manually. How to create. This is here. Let's continue with that. So we go to the modeling, create a tool. My new tool, I would put self-made tool. Use existing, select component, use existing. And then mass is 1 is for Z, the center of gravity. We can give like what is the center of gravity on X direction, on Y direction, or Z. If you have a real tool, you need to measure this like precisely, but right now we don't have. It's just simulation. I just show here the center of gravity, the mass. I put 1 kilo, so it can simulate. Next, we will select the frame that we have. This is the frame 1 that I have in the left, you can see. And just import it to the right. That's it, if I'm remembering correctly. Yeah, this was 50. Imported this. The next slide, we will go here. Oh, yeah, that's it. When you did this, just done. And this is our tool. Now the system recognizes it as a tool. Okay, so that's what we don't need. Now let's go import our robot. IRB 1008 kilo. And from now on, everything is normal, the same way that you were adding the tool to the robot. Yes. Now we have the tool installed to the robot. And the next part is, for example, we have a cable that is needed to be connected to the robot. We have this option here, cable, in the modeling tab. And for that, I want, for example, to be 5 millimeter radius. I want it to be flexible. Then I would just select the surface that I want. For example, I want it to be connected, for example, here, start point, and end point, I want it to be here. And you can see start, end point, and here in the table also. I have, and if I want a control point added, because in the installation you will need like to make sure the cable is going through the correct places. So right now I have, this is like, I could have given color to that, but it's fine. Now we got all that we needed. Start and approach point, the control point. You can have more control point. Create. So I have a cable now simulated in my robot. that when I am programming, I will know. Oh, so I need actually a cone here. We have defined the cable simulation, the tool is defined, and now we want to make a cone. For the cone, let's make the base center 700. But I want to do what was in there. So 150, 300, and the height was, let me check the height. These are what we did. This, now we want this cone. 150, 300, 500. Let's place this where it is. 500, yeah. And great. I would change the color as usual. Where is this part one, the cone? I would change the color to, it's just for visibility, nothing else. And so now we have a tool, and we have a tool, a cone, the cable is simulated, but the tool is not teached. The tool, the TCP of the tool, we need to teach to the controller that what is the X, Y, X, Y, and the Z for the TCP. The coordinate of the TCP relative to the this robot caliber, like wrist. We have to like tell this coordinate of this position. For that, we will we have a way for teaching the TCP of the robot. So let's do that. Right now, I want to move the TCP to tip of this. So I would use this tool. Oh, making controller. We don't have it yet. Home from the layouts. Let it be ready. Then I will teach home position, which is here. Then I will bring the robot to the TCP. We need for teaching the new tool, we need to put the tool in one spatial point, right now the tip of this cone, and we have to put 4 different configurations for the robot for reaching here. Based on those 4 different configurations, the controller can calculate how what is the XYZ for this tool center point. So our controller is ready. I go here, 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 here. I don't know any faster way, but I guess that is it. Yeah, very good. So this is one configuration. I would save this target. So, and then look what I'm doing. I'm trying to give different configuration. This is the second configuration I want to use. Then the red, if I can, the red. And then I'm just making different configurations each. And one more, let's make the other way. Yeah, I guess these are fine. Teach that. So for teaching under the controller, you get this teach pendant. I will bring the teach pendant here so you can see what we mean by this. Let's go in the home layout. switch to the, make sure the positions are teached, all of these 4 position. I will activate view robot at target. So any position that I click on, the robot jumps there. In the first position, I have the teach pendant. Let's activate the jogging, and jogging under let's make it enable manual, enable motor should on. Now we go to the, right now there's tool 1 only, there's nothing recognized, but let's show detail. If I go under this movement based on the TCP, and I try to move, you will see what's happening. The TCP is moving away from our tip of the cone, but that shows that the TCP is not teached. So the robot, right now I will click on jump to the target. No, I want jump to the target. No. So as you saw, when we are moving the robot, the TCP is moving away. This shows that the TCP is not teached. For teaching the TCP, I will use this program data menu, tool data. As you can see, there is only one tool here, tool 0, which is the cal of the wrist of the robot. It means there's no tool recognized for that. I will define a new tool, self-made tool, and the position task, these are dimensions we don't need to put right now, it will detect automatically. I put OK. So this is the tool. Now cancel. We say edit and define. For defining, we use the 4 point. If you use more points, that's even better. But for 4 points, I will just move the robot to this configuration right now and press define. I will move the robot to the second configuration by clicking to the second and modify position. It saves these positions. The third is this one, modify position. I try to make it quick so that the video is not long. Modify position. So, and when everything is done, you press OK. And you need to come here. There's some setting that everything is okay, it seems. It didn't give me any error or anything. You press OK. And then you click on the tool, you come here, one setting we need to, the mass -1 is not correct. We should make 1 that we put before. And now we have the tool ready. Now we go to the jogging that we did the same. Here we will have the self-made tool. And now you can pay attention what happens when I am when I am trying to move the robot around TCP with these coordinates. What happens? Error happened because it could stop. Enable motor should be on. How to run. Disable to run. Motor run. Now I will try to move. As you can see, I'm moving and the robot turning around the TCP and keeping the tip of the tool on tip of the cone as we want it. It means the robot is recognizing the TCP now. Now I can just, yeah, this was all. This is all we need to know about the teaching the tool. Now we can use it as a usual, um, like as a usual tool that we had. So let's stop here. Okay, for the first time, for the first part, we just made the new self-defined tool. We teach the TCP and simulated the cable. And this is where you have to make a video of that and put it in the exercise 7. The second part of the exercise 7, which is more important, is this file that you have, a start file. You will download it. It is similar to this one. So you should have a pen tool or my tool in the start file. Doesn't matter. You just first, when you open the file, you need to make like square, two square, small square, big square, and a round. And then, like as you can see, when I run this simulation, this will be just making one round on every every model's edge. So this is all what it does, but I will modify the rapid so that I can determine by the teach pendant, the operator can tell which one of the shapes the robot has to, for example, is welding, which one of the shapes need to be welded and how many times, because sometimes some operations need to be repeated like 2 times, 5 times, 3 times. So this is we have to communicate with the teach pendant, because the ABB robot teach pendants have the possibility to get input and show messages to the operator. An operator is able to insert some information, some number, some whatever it can be typed, and the rapid program can get. So again, I will put this to C. You see, it is first make sure that you have placed the like the cylinder and the cubes in a place that robot is easily reaching to all of the positions, can make the shapes, so that this part is for sure that is working. Later you make the logic for the communication with the teach pendant. I make a pause and add the code. Okay, now I have added the command to the rapid and modified it. So when I play, you can see what happens. There's a pop-up window. This is on the teach pendant. This is our teach pendant that we can see. On the teach pendant in the communication, there's a pop-up. And here it asks, enter the number of the procedure. This is previously I entered, but right now I will enter another. Enter the number of the procedure. For example, I will say the 1. And then okay, then it will ask me how many cycles I want it to be done. For example, I put 2 cycles I want it to be done, and it will go to the program and do it twice, and that's it. Every time I press this cycle, this will pop up the question for me, and I have to enter again, like this time number 3 and 1. Okay, it will go and do this procedure for number 3 one time. Yeah, this is all that you need to do for the task 7. You have the start file, then you will, it's like developing based on the previous tasks that we have learned. All of the commands that you need is included in the lecture 6 materials and exercise 6. So you need to just refer to there and like study them carefully so that you can be able to do this task. Okay.